Welcome everyone, I am Ujjal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1605, which is find valid matrix given row and column sums. Let's see the problem description. You are given two arrays, row sum and column sum of non-negative integers, where row sum I is the sum of the elements in ith row and col sum I is the sum of elements of ith column of 2D matrix. And in other words, you do not know the elements of the matrix, but you do know the sums of each row and columns. Find any matrix of non-negative integers of size row sum dot len plus col sum dot len that satisfies the row sum and col sum requirement. Return a 2D array representing any matrix that fulfill the requirements. It's guaranteed that at least one matrix that fulfill the requirement exists, which means the problem statement says we are given the all the row sum, row wise sum and column wise sum, but we do not have any elements or any 2D matrix here, just the sum of each row and sum of each column, and we need to find out the actual 2D matrix which fulfill the row sum and column sum, and we need to return the 2D matrix here, and it will be non-negative integers, all the elements. And let's see the constraints are length of those given integer arrays, which is row sum and column sum, will be less equal to 500, and elements should be will be 0 to 10 to the power 8, and the sum of all row sums, all sum of the all row sum will be equal to sum of all the elements in the call sum. So let's see how the problem will be solved. I will explain you the algorithm in like a visual form. Let's see the first example here, which is row sum is 3 8. Here the row sum is 3. Let's see that this is row 1, row 2, and this is column 1, column 2. Row sum is 3 8, and the column sum is 4 7. So 4 7. So what we will do, we will traverse the whole matrix, and for every row we check what is the possible number we could put in the current uh, like current cell or current position. What could be the uh, possible integer we could put? The possible integer is minimum of the row sum current row and column sum, minimum of the column sum of the uh, current column. So for 0 0, for this element, the minimum of this row and this row is 3. So we put 3 here, and we subtract 3, subtract 3 from here, so it will be 0, and 3 from here, so it will be 1. Okay, next for this element, which is 0 1, for this position we see what is the minimum of this row and this column, which is 0. So we put 0 here, and no need to subtract anything because it is 0. For 1 0 will be the minimum of a row, this row and this row will be 1. So we subtract 1 from here, it will be 0, and subtract 1 from here, so it will be 7. Now for the last position, which is 1 and 1, the minimum of this row and this column will be 7. So we'll put 7 here, and we subtract 7 from here, it will be 0, and it will be 0. And our required 2D matrix, we got the matrix. It will fulfill the both two condition, which is the row sum and col sum. So the row of first the sum of first row will be 3, and second row will be 8, which we already knew it should come 3 and 8, and the sum of all columns of first column will be 4, and second column will be 7. So it fulfills both the condition. So it will be one of the solution. There could be possibly more solutions, but we need to return any one of them. and there must be any one solution must be present. Like this line says, any matrix fulfill, it is guaranteed that at least one matrix will fulfill the requirement. So let's see how the code will look like. So first we will create a 2D matrix. So we need the row column. Let's say row is row sum dot size. It is the number of rows, and column will be called sum dot size. Because the question already said we need to make a 2D array of row 1 dot length and call size dot length. That's why this will be the number of rows, n will be the number of rows, and m will be the number of columns. So now make the 2D array. Vector print. Let's answer of size n. Then so we got the 2D matrix. Now all the elements of this 2D matrix is by default 0, and we'll um, modify the 2D array by like this. Traverse the whole matrix, int I equal to 0 and less than s plus, or j equal to 0, j less than n, j plus plus. So as we already seen here, so we calculate the current row and current columns minimum, which is minimum. So we see int mm equal to minimum of row sum I and call sum j. So mn will be the minimum of them. So we will add answer of ij plus equal to mn, and we will subtract that from the current row sum and current call sum. So row sum I minus equal to mn, call sum j minus equal to mn. So now we done all the works. Now after this nested for loop, we already have our uh, required 2D matrix. So just to need to return the matrix, return answer. Let's see, will it work? So accepted. Let's submit it. You can see it is accepted. So let me discuss the complexities. So the time complexity for this algorithm is, you can see here, it is for every row, it is running m times, which is the number of columns. So the overall time complexity is big O n cross m, where n and m the number of rows and number of columns. And the space complexity is also big O n cross m, because we are creating a 2D matrix. So the overall space complexity also big O n cross m. So that's it for today. See you in the next video.